Hi, and welcome to our 23rd test and measurement video on today's amazing oscilloscopes. Right now we'll focus on a handheld as opposed to bench instrument, the Fluke 19502 Scopemeter. In Fluke's 190 series, this oscilloscope has two channels with a bandwidth of 500 megahertz. The sampling rate is 5 gigasamples per second. All controls are on the front panel, directly below the display. On the top, at either side, are B and C connections for analog channels 1 and 2. They accept the individual probes, which have a 10-to-1 attenuation ratio. Like other handheld oscilloscopes, the analog channels are completely isolated from ground and from each other, which makes it safe to test circuits where one or more terminals or conductors may float at a significant voltage above ground potential. This Fluke instrument is known as a Scopemeter because in the middle of the top panel, between the two oscilloscope B and C ports, there are the analog channel inputs, and two banana jacks are provided for standard test probes, enabling connection of digital multimeter functions. Now we'll see what this Scopemeter can do. We'll connect the oscilloscope probes first to a DC source, a simple 9-volt battery. This instrument is so sensitive that after connecting the probe, it displays a noisy phantom sine wave that comes from the premises wiring. As soon as we complete the circuit to the object under test, the auto range feature suppresses the phantom signal. When connecting to utility power, there is a potential shock hazard and enough available fault current to cause an arc flash, so precautions are in order. A good way to access the power is to use a heavy plug and cord with a deep plastic wall box. Make the hot and neutral wires different lengths so they cannot contact one another. Strip off just enough insulation and cut the wires short so there is no energized copper beyond the rim of the box. For another demonstration of the Fluke's handheld oscilloscope's clear display and efficient operator interface, using a BNC cable, we've connected the output of a Tektronix MDO 3104's built-in arbitrary function generator to one of the Fluke 19502's analog channel inputs. Notice that the sine wave shows up in the Fluke machine's display. Using multipurpose knob A, we can scroll through all the Tektronix internally generated waveforms. Following each transition, there is a brief period of instability. The Fluke auto set kicks in and the display becomes clear. The Tektronix auto set doesn't do anything in this instance because the instrument is just outputting signals, not triggering on them. Besides sine wave, other waveforms generated by the Tektronix AFG and transferred to the Fluke are square, pulse, ramp, DC, noise, sine x over x, Gaussian, Lorentz, exponential rise, exponential decay, Haversine, and cardiac. Thanks for watching. In our next video, we'll look at some more features in the amazing Fluke 19502, including how it responds in a noisy electrical environment and its sophisticated math capability.